On this video, I want us to discuss the two types of circuits, which are parallel and series circuit. So we're gonna start with series circuit. The reason I want to do this is because I want us to understand the differences between we get deep into the syllabus, or rather calculations, or anything related to the circuits, because that's what we need to do. Remember on the previous video I showed you Ohm's law, because also it is the basic. If you know Ohm's law, electricity is not going to be that hard for you. Yeah, so series circuit. So the series circuit, you're going to see it like this. Let me take these two resistors now, or rather let me just say loads or whatever now. But just see the positive, negative. All you're going to see is that the negative of this load is connected to the positive of this load. This is a series circuit. So my lecturer used to show us like this. Used to draw two people. Oh my goodness. I don't know how to draw. Yeah. So he used to say, when you see your loads or resistors, because mostly we use resistors when we are doing our calculations, when you see them holding hands like this, only one hand, it is series. Yeah, they are connected in series. You get it, most. This hand of this resistor is connected with this hand of the other resistor here. Let's just say this is our connection here, limonana, as you can see. So this is how we're gonna see if this circuit is connected in series or parallel, right? Then we're gonna talk about how we're gonna calculate our resistance. So the total resistance of our series, it is going to, let me first draw. Excuse my bad drawing, guys. I'm really bad at drawing. So obviously this is our supply and this is our, let's just say R1 and R2. This is our VT. So how are we going to calculate our resistance? Is RT equals to R1 plus R2. This is how we're going to calculate our RT. So if we add another resistor here, if we're going to add another resistor here, which is R3, we're gonna add R3 here, right? Yes, understood. So let's go on. So if we need to calculate our current, you need to know the current is the same. The current that flows throughout the circuit is the same current that flows through here and here and here. So if our total current here is 3 amperes flowing in, meaning we're gonna get 3 amperes here, we're gonna get 3 amperes here, 3 amperes here, and out 3 amperes, right? There's nothing that disrupts the current. It flows more. Like 3 here, it gets in here, it doesn't have to split or whatnot. So meaning the whole 3 is in here and out, until everything is complete. So IT, oh my goodness, sorry about that. IT equals to I1 equals to I2 equals to I3, right? So if we need to calculate our voltage, this VT equals to V1 plus V2 plus V3. So VT equals to the voltage that's here and here and here, altogether, the sum of the voltages, the sum of the voltage drops rather. So this is how you're gonna calculate your VT. But I'm going to show you a lot of ways once we get into calculations. So right now I just wanted to show you the differences between series and parallel. That's what I want us to focus on right now. So these are the things that you need to know about series circuit. Going to our parallel circuit, going to our parallel circuit. So parallel circuit, my lecturer used to also, remember I showed you the two people there. I'm also gonna show you here also more. So parallel, he used to draw it like this and say these two people are holding both hands like this. So I was gonna show you. So as you can see, both of these people, both of these his hands are holding this person's hands. So meaning if here it's positive and here it's negative, this here it's positive and this here it's negative. Sorry, negative. So this is how you will differentiate between series and parallel. Parallel, positive to positive, negative to negative, with only two people, two resistors, right, when they're touching with both hands. So let's get into it. So let's just say our circuit is like this. As you can see, both these people are holding hands like this. Well, their hands rather meet here, and both of these also. Yeah, and this is our supply. So how to calculate our, let me start with current. Current here is not the same throughout. So the current that flows here, when it gets here, it splits into two, right? It splits so that the other one can go in here and the other one could go this direction, right? And also when it gets here, it's going to other splits again, until each current is splitting. If it can more, it's gonna go out, even this one, then it meets again and be the total current again, right? Yeah. So our formula for current is going to be IT equals to I1 plus I2 plus I3. Remember on the previous video regarding series current, it's IT equals to I1 equals to I2 equals to, you see, the current is equal throughout. Then yeah, when we need to calculate our voltage VT, you should know that VT is the same throughout the circuit. 3 is the same throughout the circuit. If you put your voltmeter here, connect your voltmeter, you're gonna get into, if it's 12 volts here, if you put your voltmeter here, you're gonna get 12 volts. Yeah, 12 volts here, 12 volts. Hence, it is the same throughout. Then when you calculate our resistance RT, so the parallel is 1 over RT equals to 1 over R1 plus 1 over R2 plus 1 over R3. This is how you're going to calculate your parallel resistance. So these are the differences that I wanted to show you regarding parallel and series circuits. So on the next coming videos, we're going to be discussing further on these circuits and doing probably calculations regarding them. So thank you for staying tuned, guys. Bye.